right, guys, it is Friday afternoon on August 28th. I hope all of you are doing very well. We've made it through the second week. I apologize that things are a little bit slow moving, but I guess that's how things are going to be for the foreseeable future. But we're going to get moving here, and I'm going to have you guys start going through the information Canvas using CDX. Okay, so here is chapter 36, Wheels and Tire Theory. We are going to have you start going through this chapter, and I am going to assign some due dates to the quizzes and the chapter exam. I didn't realize this was already published, and so I've had a couple students already go through it. So those of you that have already gone through some of this stuff, I would really appreciate it if you take a good listen to what I'm saying here. I'm going to present some different information, different from what you are seeing through CDX. I'm actually going to use some Toyota information because I really like their presentation. And also, please take a good look at these YouTube videos that I have here. These are really fun to watch. This one's about oversteer, understeer. This one's talking about how the tires are made. And same thing here. You know, this one's a little bit longer. I'll only show this one for a few minutes. These are very interesting here. How much tread depth do you really need? This one is kind of scary when you watch it. Just has testing of vehicles with different tread depths and how that affects braking on wet surfaces. This one's how to read a tire sidewall. And this one's dangerous tires. I mean, this is pretty scary, some of the tires, what they will do to people. I'm also missing my other favorite one that is, it's going to be in the servicing wheels and tires because they are dangerous for those of us that are going to be handling them. This chapter right here is more about how tires are put together, what their function is, the tire construction, the design differences, tire sidewall data, and fundamentals. So without further ado, I am going to get into this presentation, hoping that I can make it where it doesn't show the slides. I want just the pure slideshow. All right. There we go. All right. So again, we are going to talk about the functions of the tires. We're going to identify and explain the construction, size, speed, and load ratings that are listed on the side of the tires. We're going to explain the importance of maintaining OEM equivalent tires on the vehicle. I know a lot of people want to put aftermarket rims and tires on it, but we have to understand that that can present all kinds of other problems, and a competent shop can overcome those problems. Just throwing a set of tires and wheels on a car, you really need to know what you're doing. And you can open up a whole can of worms with liability if you're putting the wrong tires and wheels on a vehicle. And last, we're going to be taking a look at the basic dimensions of wheels. Okay, so the tires, they're going to serve some very important functions. They're going to support the vehicle's weight, absorb minor road shocks, transmit braking, acceleration, and cornering forces. And so the forces of cornering, road shock, braking, and acceleration are transmitted from the road surface to the vehicle through the 4 contact patches where the tires meet the road. Both safety and satisfaction are compromised if these forces exceed the customer's comfort level of the tire's traction capabilities. A comprehensive understanding tire and wheel basics is necessary in order to diagnose vehicle handling concerns and tire wear patterns. The manufacturer of these vehicles, when the vehicle is brand new, they spend a lot of time choosing the tire and wheel package that they are going to put on the car. Again, this is the only contact that the vehicle has with the road. And that contact patch at these 4 tires is very, very important. And by just changing the tire, the type of tire, the brand of tire, the compound that the tires are made out of, all of that stuff, even the tire pressure can greatly affect how the vehicle goes down. All right, so let's take a look at how some of these tires, not some, how modern tires are put together. So we've got the carcass or body plies, bead wires, belts, and within the steel belted radial tire, there may be comprised of different combinations of polyester, nylon, rayon, and other material along with steel belts. And then that's going to make up the sidewall, and then on top of all that is going to be the tire tread. So radial ply tires have ply cords that cross the tire perpendicularly from the bead to bead. And so this design is going to reduce tread squirm because the sidewall flexes as it meets the road surface. And that's going to reduce tread deformation, also reduces a radial tire's rolling resistance. So back in the late 60s, early 70s, we made the transition from bias ply to radial ply, and we were able to make not only the cars got to handle better, the cars would go straighter when you hit the brakes, but also we were able to get improvements on fuel economy up to 20% over bias ply design. Also, rigidity and strength are added to radial tires by wrapping belts around the tire's circumference between the tire tread and the ply cords. However, this added support does slightly reduce low speed ride quality compared to bias ply design. So the tire, we went to the radial ply tire, they became stiffer. And so the stiffer the tire, you're compromising ride quality. So, and if you look at how we have cars designed today, the size of the sidewall went from being like a 60 or 70 series tire, which is a very tall, thick sidewall, and now we're down to like 50, 40, 30, and those tires are really, really stiff, and it's going to affect how the tire rolls down the road. Radial tires reduced rolling resistance, they improved handling, they have extended tire life, and have brought radial tires into universal acceptance. And because bias ply tire designs can cause several handling and ride quality concerns, replacement tires should always be equivalent to the OEM in construction, type, speed rating, and load ratings. Never put a bias ply tire on a newer vehicle. All right, so let's take a look at some of the different, run flat tires. Okay, so these tires can be driven with no air pressure for about 100 miles at 55 miles an hour, and it's made possible through durable inserts in the sidewall. So the sidewall is very, very thick. This makes a heavy tire, which is not good for unsprung weight, but it definitely makes it so you don't have to have a spare tire in the car. Due to certain characteristics of run flat tires, it might be difficult to visually detect when a tire actually has low air pressure, and so therefore cars that were originally equipped with a run flat tire had to have a TPMS, or a tire pressure monitoring system, to notify the driver that there is low tire pressure in that tire. Okay, so make sure that you guys, we do tire repairs. We got to make sure that we are adhering to standards when, especially when working with tires. All right, so here is all the information that is located on the sides of the tire, or on the side of the tire. I'm not going to go through all of this. I would like you to watch the tire sidewall data video that I have in the module. It's going to go through all of this. There are 3 different types of tires that the gentleman will be talking about. And what I mean by that is radial tires like this that are metric size. We're going to have standard size tires, and then they're going to have high flotation size tires. It's going to go through all of that. So I need you guys to Okay, and then the different types of tires that we might have on the vehicle could be summer. We could have all-season tires, and then we could have snow tires that we would only want to use in snowy conditions because they will have studs put into the tire tread. That way you don't have to put chains on the car. All right, so take a look. We have P for passenger car, 205 is the cross section width in millimeters, 65 is aspect ratio. So that means that the height of the sidewall is 65% of 205 millimeters. Let's just use easy math. If we had a 100 millimeter wide tire and we have a 50 series tire, that would mean the sidewall height from the rim to the tread would be 50 millimeters, 50% of 100. Okay, so R stands for radial construction. 15 is the rim diameter in inches. The load index there is 92, and this tire has a speed rating of H. They come in all kinds of different load indexes and speed ratings. Whatever the car had on it, you could put a speed rating that is the same or higher. You cannot go lower in speed rating. Okay, so the aspect ratio, also known as the profile of the tire, again, is just a percentage of the sectional width. So you can see here that a 70 series tire is going to have a very tall section width of the sidewall. So you can see that this is going to be old school tires. Okay, now the new school, and even this is beginning, 50 series tires kind of old school now. If you go look at newer cars, they're going to have 40s on them, 35s from the factory. The tire sidewall has continually gotten shorter over time. Okay, so here's the service description. Again, the load index, the load capacity, and the speed rating. There are charts that you can look up. You don't need to memorize this. You just need to understand, again, that if the car requires a tire that can handle 1,389 pounds of weight on it, you cannot go lower than this. If something was to happen to that car and you put a tire on that, there would be a lawsuit. Okay, you can kill people. So there's no problem with going as much or greater than. That's fine. Same thing with the speed rating. If it had a H tire that's rated to 130 miles an hour, you can put an H tire, or you can put ones that can sustain higher maximum speeds, but you cannot go less than what the vehicle was originally equipped with. All right, so here we go. Load and inflation limits. So pressurized air inside the tire supports the vehicle's load. The required inflation pressure increases when the load applied to the tire increases. So heavy loads amplify tire flux. This causes the internal tire temperature to rise. The extra heat weakens the bond between the individual tire components and causes tread separation and/or failure. Maximum load and the corresponding inflation pressure to support that load are specified on both passenger car and light truck tire. So I just want you to understand that there is a maximum load and maximum tire pressure on the side of the tire. Also, there is a tire inflation placard or sticker that is in the driver's door jamb. And it will tell you what the maximum tire pressure is for the tire that is supposed to be installed on the vehicle. Now, if you are going to overload the car, what this was just saying is that you would have to put more pressure in the tire. Now, the engineers who chose the tire and wheel package also chose what tire pressure that the stock tire should be inflated to, and that pressure is good to handle the gross vehicle weight even when it's fully loaded. So you should not be messing with the tire pressure. You should be setting the tire pressure to what is indicated in the driver's door jamb on the tire inflation placard. All right, so let's see here. On the side of the tire, it's going to have this DOT number. It will show you the tire manufacturer and what plant it came from, the tire size, so this is their serial number, manufacturer's code, but to us, the most important information is actually these last 4 digits of the tire serial number. And this will tell us the production date. So for example, this tire was produced on the 37th of the year 2001. So we really should be taking a look at these tires. Once they hit about 10 years old, they are done. They should not be on the car. All right, so now we're moving on to the wheel and how all its different parts and how and its dimension. So the wheels transfer the forces of acceleration, braking, and cornering between the tire and the suspension of the vehicle. And wheels typically consist of 2 primary pieces that are constructed of either stamped steel or a light alloy. The center section or disc contains 2 items: the spindle center hole, or the pilot, and the wheel stud bosses, the mounting holes. The wheel can be centered on the hub by either the spindle center hole or the wheel lug nuts. So that's either going to be hub centric or it's going to be lug centric. So we have the different parts here: the bead flange, the bead seat, the safety bead, and that's used for flat tires, and it's required on both sides of the rim. And we have what's called the drop center, and you can see the drop center here is the most narrow part of the rim. That's so we can actually get the tire rim itself. And then there is a hole for the valve stem to come through. So the valve stem has to have a hole that it can pass through. All right, so width and diameter are the primary dimensions for automotive wheels. The distance across the inside of the rim between the bead flanges is the rim width. We're talking about right here. The wheel diameter and the distance across the center of the wheel from one bead seat to the other. Sorry, the dimension from the top of the wheel flange to the bead seat may also be included the size designation, and that's called flange height. For example, a 14 by 5 by 1.5 JJ wheel is 14 inches in diameter, 5.5 inches wide, and has a flange height of 17.5 millimeters. So if you're ever looking at an, you'll find this on an alloy wheel. Unfortunately, I do not have a picture of it, but you'll see this marking that says JJ. What the hell is that? That's actually indicating the flange height, and that's the distance from the bead seat to the flange. All right, we're almost done. Okay, so the diameter circle formed by the rim's mounting hole is called the bolt circle, and they're commonly going to be like 4.5, 5.5, 5.9. We can also have them in metric, 100 millimeters, 120 millimeters, and so on. And we also can have the wheel retained to the flange in a couple different ways using different nuts and bolts. And so I'm going to switch over to the whiteboard just to show you what I mean by that. So we have a couple different lug nuts that are available. Right. So let me get over to my whiteboard, and I want to draw a couple different lug nut styles that we have. So all lug nuts have a taper, and this taper forms an interference fit with the rim. So if that's the rim, and the stud or lug stud is going to pass through the lug nut like that. So it's very important to understand that this taper goes into the wheel. this type of lug nut that I've drawn here, sometimes students, rookie students, will try and put this end in the flat part of this on the vehicle. And if you do that, you'll destroy the tire, sorry, you'll destroy the rim. Okay, so remember the flange of this taper has to go into the rim. So there are other lug nut designs that is impossible to do. You can only go put it on one way because they have a cap on it. And that would be an acorn style lug nut. Then there is the Germans and the Europeans. They don't use nuts, they use stuff, they use like a bolt. So same thing, you have no choice. You can only put this in one way. It comes to a taper like this, but then it's a bolt. So BMW, Mercedes, all the Volkswagens, all of the Volvos, they're a real pain in the butt. These guys make it very difficult to put the tire back on the car. And in fact, they make tools where you thread a stud into the flange and it makes putting the tire wheel back on the car a lot easier. Anyways, let's get back to this so we can finish this up. Get rid of my whiteboard. There we go. There we go. All right, so our last slide has to do with how the wheel is designed. So if we have this at the center disc of the rim in the perfect center line of the rim, this is supposed to be 0 offset. So if we have, and let me give the example of this, and we're just talking about the offset. This has nothing to do with the back spacing. The offset does affect the back spacing, but the offset is just telling us, are we positive, are we negative? It doesn't give us a number. The back spacing is actually the number. It tells us the number of inches or millimeters from the straight edge put on top of on the back of the wheel from this rim flange to the face of the center of the rim. Basically where the back of the rim is going to contact the axle flange. So I know this is a little bit difficult to understand what you're seeing here, but this is the axle hub or the flange, and this light gray is the rim. So where we're measuring from is the backside of this rim flange right here. Go back to this. So back spacing tells us, well, how far away is the flange of the rim to the backside of this rim flange. So if we have a deep dish wheel, it is going to have where the flange of the center of the rim is sunken in. So this would be looking from, this would be from the outside looking in, and this would be the side of the car. This deep dish style is said to have a positive offset. Whereas if you look at a front wheel drive car, the front flange is typically really close to the rim flange, to the front of the rim flange. And so when you guys are, in the parking lots, try to pay attention to what you're looking at. You're going to find that front wheel drive cars typically have a negative offset, meaning that the rim flange is very close to the, or the holes is very close to the front wheel, the front flange. Whereas rear wheel drive typically have more of a positive offset. And that just has to do with the difference in, front wheel drive versus rear wheel drive and how that affects the suspension. Anyways, that is enough for this as far as we need to go when it comes to the PowerPoint. Again, what I would like you guys to do is to look through all of this stuff right here. I'm going to work to create the videos that is needed for this troubleshooting tire vibration. We're going to take a look at this TPMS because that is covered in this chapter. So what I would like you guys to do is to work through 36.3. I'm going to set the due dates. So this is going to be due by Monday. And so it's going to be chapter 36 through point 3. The quiz needs to get done. I apologize. And then we'll actually 36.2, and then we'll take a look at all of these. I'll create these. Unfortunately, these are Honda videos, and you do not have access to them. And I would typically share them in a classroom. I'll make a video of them and I'll share them with you in that way. Anyways, so if you guys have any questions, comments, please let me know and I will be more than happy to help you. Again, I'm here to help you guys out. I will be posting up very soon the schedule for next week so you guys can come in. Those of you that did make it, I hope you enjoyed your time in the shop. We are going to start playing with tires and wheels and doing some mounting, dismounting, and balancing and tire repair. That's what we're going to be concentrating on next week. So I hope you guys have a good weekend, and I will be seeing you guys very soon. Take care.